In Lesson 5.1, we're going to be looking at the exponents and how they're related to a radical. A fractional exponent actually is related to a radical. So it says, what are the real cube roots of 125? Most of us are familiar with square roots. For example, we've seen the square root of 25, and many of us can respond with the answer is 5. Now recall that means that 5 times 5 would give you 25. We also need to note that negative 5 times negative 5 would give you 25. So sometimes when you take a root, we can have a positive and a negative answer. Now, we always use square root. Again, square root of 9, we're used to. That means it'd be 3 because 3 times 3 makes 9. Square roots are very common, but there can be cube roots. When I say square root, that means it was 5 squared that made this number. We don't put a 2 here, but there could be one. So when someone wants the cube root of 125 here, that means you want to think some number times another times itself again should make 125. You might have to play around with it, do some guess and check. As we start out, we'll generally be using whole numbers, but think about the number 5. 5 times 5 makes 25, and 25, think quarters. 5 of the quarters would be $1.25, so that would be our perfect real root of 125. Negative 5 is not going to work this time. Note that if it was negative 5 times negative 5 times negative 5, it would be a negative 125. So we would not say negative 5 this time. That only worked for the square root up here. So for the answer to example 1, we would say the real cube root of 125 is 5. We just state the number that had to be cubed to give you 125. We could look at this real fourth roots of 16. So that means what number times itself 4 times would make 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we'd say our answer here is 2. In terms of some vocabulary, when it comes to taking a root of a number, our radical is this symbol. A radical is the root symbol. The index is what root you're taking. Sometimes we refer to it as the nth root. So you may even think of this nth part as what number goes out here. And then the radicand is the number under the square root. We'll refer to those vocab words at times, so keep those in mind and maybe take note of those. Looking at the try it number 1, we can see, again, we have the fourth roots of 81. So you could be thinking what number times itself 4 times will make 81, and we could go that route. Another way to think about it is here, this fourth root of 81. You can see our radicand and our index and our radical there. We are using those vocab words. You could actually think of it as the square root of 81 is 9, and then the square root of 9 again is 3. So basically what I did is I knew that I wanted to take the square root of a number. If I took the square root of 81, I felt good, but then I'd have to take the square root again. So see how this 2 and 2, this isn't really the true math way of looking at it, but you could think of it this way. If you can take the square root of 81, you're getting 2 of those roots out, and then you take a square root again. So the square root of 81 would become 9. And then I'd have that square root left from out there, so the square root of 9 would become 3. And if we tried that, 3 times 3 is 9, times 3 is 27, times 3 is 81. So our answer for this is 3. And this one could have a negative 3, because a negative times a negative is a positive, and a negative times a negative is a positive. So you would actually get a positive 81. Again, with this fourth roots of 64, if I try it that alternate way, instead of taking the fourth root, I could take a square root of 64, but then I'll have to square root it again. So the square root of 64 is 8. And actually, I just realized something. This one won't come out pretty. Believe it or not, I'm glad I saw this. This is actually supposed to be a third root. A little typo there. So change that in your packet. Let's try that again. So if it's the third root, we actually want to think what times itself will make 64. Okay, well, let's try 4 times 4, which is 16, times 4, which is 64. So our answer here would be 4. Sorry about that one. Make sure you change your packet there to the third root of 64. Now in example 2, they're asking for what it means to have 16 to the 1/4. Now we're getting exponents. We're not looking at the roots anymore, or so it seems. If I took 16 to the 4th on a calculator in Desmos, I got 2. Well, that's kind of interesting. So I'm going to go with that because the calculator can't be wrong, right? But remember from a previous problem that we just did, 2 times 2 is 4, times 2 is 8, times 2 is 16. This 2 is the same answer as that. Believe it or not, this actually means the 4th root of 16. And you might say, well, what about this 1? I see where the 4 goes. That's the index. And I see this is the radicand. What is this 1? This is the power. We don't have to write it, but that power is the top part of the fraction or the numerator. So over here on example 2, part B, you would have 27 as your radicand. You'd be taking the root. We'd want the third root, and your squared would be your power. Now, you have a choice. You can take the third root of 27 first, or the 27 squared. I prefer not to have to think of 27 to the second power. So I'm going to do this part first. I'm going to leave that squared out for a minute. The third root of 27 means something times something times something to make 27. That's going to be 3. Now I still have that squared there that I'm going to carry down. And so that's going to be 3 squared makes 9. My final answer for B would be 9. You can try these try-its down there and check your packet for the answers, but keep in mind this concept. A rational or fractional exponent, I like to say you have the power over the root. Any base to a fractional exponent, the top one is your power, the bottom one or denominator is your root. You can take you can do the power first, or you can do the root first, whichever makes your job easiest. On example 3, they give us some more just to keep practicing. I'll look at, say, 32 to the 3/5. Remember, that's 32. The power is the top number, and the root is the bottom number. Now, whether we've done it before, we just have to think about it. Something times itself 5 times to make 32. 32 to the third does not sound fun, so I'm going to see if I can focus on this part. Turns out that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That box there simplifies to 2, and now I can take it to the third. Well, 2 times 2 is 4, times 2 is 8. You can use a calculator for this, but you're going to be expected to show your work on how you broke these down. So use your calculator to check, but we want the exact answer in your work. Now, whenever you have a negative exponent, it will change the location of the value that you raise to that power. So this 27 to the negative 2/3 really can be written like this. And now I'll leave that 1 on the top, but this is the third root of 27 squared. I try to avoid squaring really large numbers like that. 27, the third root of it is 3. So 3 squared would make 9. You can check the book or your packet key for the answers to this third part or this story problem, but let's try one of the try-its. You see, this negative sign has nothing to do with the exponent, so it's just going to float along out front of your answer. 16 will be to the power of 3 and the root of 4. This first part, again, if I can avoid it, I don't want to get 16 to the third, so the fourth root of 16 happens to be 2. I know that from lots of practice, but you have to think. Something times itself 4 times makes 16, and that happens to be 2. Then I take it to that third power, I'd get 8. You can check your answers for B in your packet answer key. Example 4 goes back to using that radical expression, or the radical. So you're going to have not so many fractional exponents, although you could rewrite them like that if you wanted to. One thing we're going to note is that you can kind of break things up. This is a lot going on here. You can actually split up each piece. Notice how I've written the 5th root of 32 times the 5th root of m to the 15th. Well, we want something times itself 5 times. That makes 32. That would be 2. So that's just this part. Now the 5th root of m to the 15th. We have to remember our exponent rules, that when you are multiplying like bases, you would add the exponent. So 3 plus 3 is 9, plus 3 is, or 3 plus 3 is 6, plus 3 is 9, plus 3 is 12 plus 3 is 15. That means this m to the 15th could be written as m to the 3rd 5 times. Well, if I want the 5th root of something that's written 5 times, it's just going to be m to the 3rd. This right here will be my final answer. Now, that's a lot of rewriting. Could you use the power over the root idea? Remember, my 15 is the power, my root is the 5. 15 divided by 5 comes out to 3. So I have rewritten each of these x to the 20th and y to the 8th out for this part B, but could I not write this as x to the 20 over 4 and get x to the 5th? Or y to the 8th over 4, which is y squared? This would be my final answer. I have rewritten each of these separate pieces here on the bottom for the triads. See what you can do for each of those and check your answers in your packet key. Although I do want to point out one thing here. Something times itself to make -8. These would all have to be -2s. This is the first time we've seen -2 be the answer for that. Now, if all that practice with the exponents or the radical view, remember, sometimes you want to look at it like it's a power over the root. Sometimes you like to look at it as a radical and just think what number you can multiply by itself a certain number of times. But now we're going to use all that to solve these. For example 5, we have 2x to the 5th equals 64. It's important first to just get that x by itself. So x to the 5th equals 32. Now, you could again guess what number times itself 5 times would make 32. You also could think of that as taking the 5th root. If you want to cancel out a 5 power, you can take a 5 root, but what you do to one side, you have to do to the other. Now, this is going to, the 5 and the 5 will cancel because remember that'd be like x to the 5 over 5, which is just x, and the 5th root of 32 is 2. Let's try one more here. I'll do part B. If you divide by 2 on both sides, we get p to the 4th equals 81. And that would mean something times itself 4 times makes 81. Again, mostly we're dealing with whole numbers here. We only have been. So we would know that 3 would be the number times itself 4 times. That would give us 81. So p equals 3. But remember, we could also get rid of that 4th power by taking the 4th root. Mathematically, that's what you're doing. So this would be a great step to show. This is kind of your guess and check way. And remember, p to the 4 over 4 just leaves p. That's why I have that there. And the 4th root of 81 is 3. For solving an equation, you always want to take, to get an x value alone, if it's x to the n, you take the nth root of both sides.